So in this video, we're going to talk about algebraic expressions. In order to do that, we need to talk first about variables. So a variable is a number whose value we don't know. So let's take a look at what variables look like. So here's an example. It snowed 6 inches more in February than in January. There's a number of ways we could rewrite this. One of them is like this. The amount of snow in January plus 6 is equal to the amount of snow in February. And this is absolutely terrible to write. It's long, it's clunky, it's hard to read and understand. No one would use this. But we can make it a lot easier to read and a lot shorter if we just represent this whole annoying mess of words by the letter J, which stands for January. And this we can represent by F, for February. So now we can rewrite this terrible thing as J plus 6 equals F. And this is really pretty. It's short, it's easy to read, and it still tells us the information in this sentence. You may be wondering if this is an algebraic expression, because that's the title of the video, but it is not. It's not an algebraic expression because it has an equal sign. So now let's talk about what an algebraic expression is. An algebraic expression is basically something that tells you what to do with a variable. So an example of an algebraic expression would be J plus 6. J plus 6 says add 6 to J, which is our unknown number, which is also called our variable. Another example could be 6 times x. Here, x is our variable, and this just says multiply 6 times x. Now that you have an idea for what algebraic expressions look like, let's do an example and then we'll work through part 4 of the problem at the top of this video. And here we are at the top of the video. So let's do an example. And our example is going to be the quotient. So we need to write an algebraic expression for the quotient of a number by the sum of that number and 17. First of all, where is our variable? Well, you'll notice we have this number hanging around whose value we don't know, so this is our variable, and we get to pick a name for it. X is the traditional name for a variable if you just have to pick one out of thin air, and so we're going to do that here. X. And this is the same number, so this gets the same name. So now I'm going to rewrite our problem. We have to write an algebraic expression for the quotient of x by the sum of x and 17. And already this is getting easier to read. We don't have this annoying a number thing. This is somewhat clunky and doesn't sound that good. This is better. Let's keep going. So the word quotient means we're going to be dividing two things. So I'm going to get our line here for division. And what are we dividing? Well, we're taking the quotient of x by this stuff. So we're dividing x by whatever this is. So x is going to go on top, and it's going to get divided by the sum of x and 17. So what is the sum of x and 17? Well, sum means that we're adding things, and we're adding x and 17. So this is x plus 17. And so in the end, we have x divided by x plus 17. And so this really short expression, this is an expression, it tells us to take x. I suppose I should keep that blue. It tells us to take x and then to divide it by whatever we get when we add x and 17. So this expression is a much shorter, simpler, and easier to understand way of writing this phrase. So now let's work on part 4. Okay, on to problem 4. First of all, if you think that you can do this problem, it would be great to pause the video now, give it a try, and then watch the rest of the video to check your answer. If you'd rather wait a while to try it on your own, you'll have another opportunity to pause the video later on into the problem. Okay, so now that you've paused the video if you wanted to, let's take a look at this. We have to write an algebraic expression for the absolute value of the difference of the squares of 6 in a number. So, first of all, let's find our variable. The absolute value of the difference of the squares of 6 and a number. There it is. There's our unknown number. And just like before, we're going to name it x. So now what we have is the absolute value of the difference of the squares of 6 and there's x. Okay, so let's continue with this. The next big thing is the absolute value, or rather the first big thing. The absolute value just means we're going to put big vertical bars on both sides of our expression. And what are we taking the absolute value of? Well, we're taking the absolute value of the difference of the squares of 6 and x. Okay, next thing. We have a difference. The difference. This means we're going to be subtracting two things. What are we subtracting? Well, we're subtracting the squares of 6 and x. So that means we're subtracting from, so we've got the square of x, sorry, the square of 6, and from it we're going to subtract the square of x. And now we're almost done. Pause the video now and try to finish it. try to finish the problem, and then watch the rest of the video to check your answer. Okay, now that you've had a chance to pause the video, let's finish this. We have the absolute value of the square of 6, which is just 6 squared, minus, let's write that in red, minus the square of x, which is just x squared. So if we put this together, we have the absolute value of 6 squared minus x squared. And that is our expression.